Hello students, so today we will learn types of matrices. So types of matrices, there are many types. So we have seen how to represent a matrix using rows and columns. We know how to write the order of a matrix. So now first type is column matrix. As the name suggests, column matrix contains only column, only one column. So for example, if you take a matrix 1 2 3, so there is only one column and 3 rows are there. So the order of this matrix is 3 cross 1. So the matrix in general we can write A is equal to Aij, where the order becomes m cross 1, that is rows can be any number and 1 is the number of column, that is only one column. So this type of matrix is column matrix. Then we have a row matrix. So in a row matrix we have only one row. So this similar matrix will write like this. So the order of this matrix is 1 cross n. So 1 is the number of rows and n is the number of columns. And in general it is represented as Aij 1 cross n. Here it will be 3 columns are there, right? So these are column matrix and row matrix. Third one is square matrix. Square matrix. So here number of rows is equal to number of columns. So your m cross n is such that we have m is equal to n. So say A equal to 1 2 3 4. So this is 2 by 2 matrix. So this is a square matrix. So similarly we can have a 3 by 3 matrix. That becomes a square matrix. Next one is a diagonal matrix. So we write this matrix as 1 2 3 0 0 0. So in this type of matrix only diagonal elements are there. Rest all elements are 0. And a necessary condition is it has to be a square matrix. So your this thing it is represented as B or this matrix A as Aij m cross m, that is a square matrix where your Aij elements become 0 whenever you have I is not equal to j. Whenever I is equal to j, will have elements other than 0 and rest all elements are 0 for I is not equal to j. Next one is a scalar matrix. So scalar matrix is again a square matrix and it is a diagonal matrix but with a special property, that is all the diagonal elements are same. So your A can be written as 1 1 1. So all the elements should be same in the diagonal. And it is represented as Aij, where it is a square matrix. So your Aij becomes equal to 0 whenever I is not equal to j, and Aij is equal to k with some constant k, that is it has to be same. So this is your scalar matrix. Next one is identity matrix. Okay, identity matrix is always represented as like this: 1 0 0 1, or 3 by 3 matrix can be written as 1 0 0 0 1 0. That is, all the elements should be 1 of diagonal. Okay, so it becomes an identity. So it has to be a square matrix, and it is also a diagonal matrix. Okay, and all the diagonal elements are 1, so it also becomes a scalar matrix. Okay, so it is represented as Aij equal to 1, value is 1 if I is equal to j, and it is equal to 0 if I is not equal to j. So this is your identity matrix. Next type is a zero matrix. Zero means all the elements are 0. So it is not necessary that it has to be a square matrix. Okay, all the elements should be 0. So for example, A equal to 0 0 0. So this becomes a zero matrix. Okay, and zero matrix is represented by like this. Okay, or it is also called a null matrix. So next topic is equality of matrices. Okay, so two matrices are said to be equal if they have a same order. They should have a same order. That becomes your first condition, same order. And second thing is each element should be equal to the corresponding element of another matrix. Okay, so if you have an element, say Aij, it should be equal to Bij of another matrix where I is equal to j, for all I equal to j. So A12 should be equal to B12, like this. Okay, for example, I'll take a matrix 1 2 0 1. So all the elements, corresponding elements should be equal. Then we say that it is a equal matrix. Both are equal matrices. Okay, so let's do some examples on this. Okay, the question is you have to find values of A, B, C and D from the following equations, and the matrices are given: 2A plus B, 5C minus D, A minus 2B, 4C plus 3D equal to 4 minus 3 11 24. Okay, so from this matrices you can write the equations. 2A plus B is equal to 4, because this element is equal to this element. Matrices are given to be equal. Then A minus 2B equal to minus 3, 5C minus D equal to 11, 4C plus 3D equal to 24. So as you have seen here, all are unknowns and we have equations in two variables. So equations, linear equations in two variables can be solved using substitution method, or you can use elimination method. Okay, so I'll use here elimination method. I'll multiply this equation by 2. So I'll get 2A plus B equal to 4 and 2A minus 4B equal to minus 6. So changing signs, so B equal to 2 you will get. Okay, using B value you can find out A value. So put this B value in one of the equations. Okay, so I'll put it in equation 2. So A minus 2 into 2 equal to minus 3. So A minus 4 equal to minus 3. A equal to minus 3 plus 4. So A equal to 1. So here we have values A equal to 1 and B equal to 2. Okay. Now let's solve other two equations. So here I'll multiply by 3. Okay, so 5c 15c minus 3d equal to 33 and 4c plus 3d equal to 24. So you'll get 19c equal to 57. So c is 57 by 19. So 19 threes are 19 threes are, you'll get 57. So c is 3. So putting this c equal to 3 in equation 1, you will get 5 into 3 minus d equal to 11. So 15 is minus 4. So d is 4. Okay. So this way you can find the values of unknowns. There is one question in exercise 3.1. Okay. Question number 10. In this they have given it is a MCQ, number of all possible matrices of order 3 by 3 with each entry 0 or 1. So we have a 3 by 3 matrix. Okay, and you have to fill these places. Okay, each entry with 0 or 1. So place 1 can be filled in two ways, right? 0 or 1. Place 2 can also be filled in two ways, 0 or 1. So like this we have total 9 places. So first position can be filled in two ways, right? So like this we have total 9 ways. So you can write the possible orders 2 raised to 9. Okay, which is 512. Similarly, if you had taken a 2 by 2 matrix, okay, 2 by 2 matrix, and each place filled with 0 or 1. So total entries are 4 and each entry can be filled with 0 or 1. So 2 raised to 4. So it is 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. Okay.